Hey guys, today we're starting our notes for atomic structure and parts of an atom. And this is actually a Nearpod assignment, so if you go back into the modules for Canvas, we have this kind of layout in Nearpod, and I do want you to go through that because there are some activities there at the end, but I wanted you to have some explanation in case you weren't on the live Zoom. So we're gonna go through these notes together. First things first, in your spiral, on page, let's see, what did we make this page? Page 7, I believe. This is where you're going to write your notes with the information. So here's how we set up our notes in science. We do it 2 columns. So on the left side is going to be your subheading, because the overall title is parts of an atom. And then on the majority of your page, on the right part, is going to be your information. So here's an example of subheading with information. On our next slide, we have our first bit of information. Our subheading is atoms. And anytime that you have a new subheading, the title up here will change, but also we're indicating that with a different background color as well. And then your information would be the 3 bullet points. So if I go back to my notes, my first subheading is atoms. And then the information for atoms is going to go right here. So at any time during the video, if I'm going too fast, you can pause. You should be able to rewind the video or back it up a little bit and get that information down, and then you can click play to continue. So for atoms, we're starting with, what is an atom? An atom is the smallest particle of a unit of matter, basically like an element, that retains the properties of that element. So the smallest piece of gold that you can have is 1 atom. And if you were to take that atom and break it apart, it's no longer gold. So it's the smallest particle of an element that retains the properties of that element. Okay? Atoms are actually made of smaller pieces called subatomic particles, and the 3 different subatomic particles are protons, neutrons, and electrons. And then atoms can bond with other atoms in order to make new substances called molecules. So for example, water is a molecule made of H2O, 2 hydrogen atoms bonded together with an oxygen atom. Okay. All right, here we have a new subheading because we have a different background color. This subheading is called protons. So one of the subatomic particles, and it's actually the most important one, is called a proton. Okay, so on your information part, I want you to draw this circle, and we're going to draw these little red pieces in here. These are your protons. Now, protons have a positive electrical charge. If you think of like a magnet, you have a positive and a negative side. Or if you have a battery, you have a positive charge side of a battery, negative charge side. In an atom, protons are your positives, okay? They're located inside the nucleus, just like in a cell. The nucleus is the center. So in an atom, nucleus is the center of an atom, and it contains your protons. They have a mass of 1. So if I have 5 protons, that adds 5 atomic mass units to the weight of that atom. Okay? And then the most important part about protons, they determine what element that atom is. So if I add another proton to this atom, I'm totally changing the identity of that element. Say, right now it's lithium. If I added another proton, I get a whole different element that would become beryllium. So protons, if you add or subtract protons, you're changing the name of that element. New subheading, because we have a new background color. The next subheading is going to be about neutrons. So in your drawing of that atom that you had on the last slide, I want you to add these 3 circles here, or add 3 more circles, and put a little 0 in there. You could put a 0 with a slash through it, just means no charge or neutral. So neutrons don't have an electrical charge like the protons do. They're neutral. That's how we get neutrons. Okay? They're also located in the nucleus with a mass of 1. So combined with the protons, you have the weight of that element. So it's really kind of interesting because if you go and you look at this atom here, you have a mass of 6. All you have to do is count what's in the middle. Mass is middle. Okay? And then the job of the neutrons is to add weight, but it's also to help hold those protons together. If you've ever tried to put 2 positive sides of a magnet together, you have that repelling effect. So the protons don't want to be touching each other. They would be pushing apart or repelling. So the neutrons kind of act as glue and holds them together. Okay. And our final particle is called an electron. So electrons are negative charges, and they're located not in the nucleus, but around the nucleus in energy levels called electron shells or electron rings. If you hear different terms, they all mean the same thing. It's just the place where electrons are located. So notice in our picture, they're a lot smaller than the protons and neutrons. We're trying to draw this a little more to scale. The electrons are smaller because we don't count them at all into the mass. I could have 100 electrons around the nucleus, but I would still only have a mass here of 6 because that's how many protons and neutrons are in the nucleus. Okay? And then the job of the electrons are to cancel out the charges of the protons. Our goal is to have an overall atom that's neutral right now. So we're canceling out this electron, cancels with a proton. This electron has to cancel with this proton, this electron and this one cancel out. And we're left with only our neutral charged neutrons. So our atom becomes neutral, and that's what we want. That's our goal. So our protons and our electrons, for the purposes of this class, should always be the same. So if I have these 3 protons, our electrons should be 3 as well to balance them out. Okay. All right, so electrons, they float around the outside. This is the same subheading, so we can keep it the same information here. Now, if you remember, or if you know the Houston area codes for your cell phone, so if you call a home phone, usually it's the area code is 281. Or if you call a cell phone, 832 would be the phone number. If you can remember those area codes, it makes you really remember how electrons go around the nucleus. So 281832. And then we drew our lines in here. So we have 2 can go on our first shell. That's all the room there is on that first shell for electrons. If we have another electron, that shell is full, then we can go to the next one. Okay, so if we have more than 2 electrons, then they jump out to the second shell. So I have 1, 2, and then 3 here would be my third one, would go on the second shell. This second shell can hold up to 8. So I have 2 on the first shell, 8 on the second. Total of 10 in this atom. If my atom has more than 10 electrons, it's going to have to jump. Hold on. I'm going to go ahead and set up the fire alarm. There's no reason to go ahead and hit your flashing or that good building. But for our newbies especially, I want to make sure that they hear and understand what the evacuation sounds like. And also, it really doesn't hurt to make sure it works. We're going to pause this recording real quick. Sorry about that. Even with you guys gone at home, we still have to have fire drills, and one just went off at the beginning or in the middle of our Zoom. So we'll continue. All right, so we have 10 total electrons right now. If we have an 11th electron that we have to include, we would then put that onto our third shell. And so you're just going to add another ring. You don't have to draw all 3 pictures. We're just adding to our original picture. Okay, and then this third shell can hold up to 18. And if we have our first 3 shells completely full, and we have another electron that we have to put on, we could then go up to the 4th shell, which has 32. Okay. Okay. So a couple subheadings left. This one is called valence electrons. Now, valence electrons are a special type of electron in the atom. They are on the outermost energy level. So if we go back to this slide here, if this was our atom here in the bottom right corner, these would all be considered valence electrons because they're on the outside ring. Okay, valence electrons, it's super important that you know the difference between regular and valence electrons. Okay, so valence electrons are on the outermost energy level. And they're important because they determine how those atoms will bond and react with each other. Remember I talked about water, for instance, is 2 hydrogens and 1 oxygen. Well, if we have a picture for hydrogen, and notice there's 1 electron on the outside, and we have 2 of them. In oxygen atom, we have 8 total electrons, so 2 on the first shell and 6 on the outer. So those 6 on the outer shell are the valence electrons. The goal of all atoms is to have 8 valence electrons. Okay? It makes them happy, makes them complete, so they want to stay in groups of 8. And if they don't have 8, what they're going to do is they're going to go find other atoms of different elements or the same element, and then share those electrons so it's in some group of 8, whether it's 8 or 16 or 24. So if we look here at water, this has 6 in the oxygen, right? So we have room for 2 more. Well, here hydrogen has 1 each. So the 1 hydrogen valence electron comes and shares here. And this hydrogen valence electron comes and shares here. And now together, they create a molecule where you have 2 or more atoms bonded together in order to have these 8 valence electrons on the outside. And then once they do that, they have a whole brand new set of properties. Like for instance, hydrogen and oxygen are both gases, but when they bond together, they create water, which at room temperature is a liquid. Okay? So this is how we make molecules, and we'll discuss more of this in a couple weeks. But this is why valence electrons are important. Okay? All right, so if you've ever seen something called the periodic table, which everybody should have, because I know they teach it back in 6th grade, you have these squares with some information about an atom. Okay, so for example, in element name is going to be in the middle, or the symbol for that. So Na is sodium. This little number up top is called our atomic number. And every element has its own atomic number. So it identifies what element it is. If I say element number 11, you would look at the periodic table at this top number, and you would realize, okay, I found 11, you must be talking about sodium, okay? What's special about this is it tells you how many protons are in an atom. So right away, if I need to find my protons, neutrons, and electrons, and you say, oh, how many are in sodium? Well, look here, atomic number is 11, I know I have 11 protons, okay? And if the atom is neutral, meaning all the protons and electrons cancel out, then it also tells you your electrons, because if I have 7 protons, I need, or 11 protons, I need 11 electrons to cancel out. Okay. The other piece of information that this square tells you is this number on the bottom. So new subheading, this is called atomic mass. So our atomic mass on the bottom tells us how many protons and neutrons there are in the nucleus. It tells us how heavy it is. And if you think back to the beginning, protons and neutrons have the weight. So first thing we want to do is always round it. So in this case, it rounds to 23. And I know that means that we have 23 total protons and neutrons. So a lot of what we're going to be doing is asking you to find the PNE, protons, neutrons, electrons of atoms. So let's work out real quick how to find that. So PNE. And we're going to do it for sodium. This atomic number we just saw tells me how many protons there are. So I'm going to draw that here with 11 protons. I also know that if I have 11 positives, I need 11 negatives to cancel them out. And so the particle with negative charge is electrons. So those have to be the same. Now, how do we find neutrons? It's not the number or the mass that tells us neutrons exactly. We have to do a little math. I know that this mass is protons and neutrons. So I have 23 total. But I already know that I have 11 protons. So if I subtract out my 11 protons, I'm left with 12 of that 23 to be my neutrons. And that's how I find the PNE of an atom. Protons, neutrons, electrons. Okay? Helps me figure out what that atom's made out of. All right. Okay. Ape man is just a mnemonic device to help you remember. Ape is atomic number equals your protons and your electrons. So we have the A, P, and E. And then the man part is mass minus atomic number. So the bottom number minus the top equals how many neutrons there are. So you can find your P and E of an atom if you can remember the phrase or the acronym Ape man. Okay? And so it shows us here, this is kind of what we did on the last slide. And then a Bohr model is a picture of that atom. And we worked on drawing those as we learned about protons, neutrons, and electrons earlier. So it was developed in 1913 by a Danish physicist named Niels Bohr. And he noticed that heavy positively charged part of that atom was in the middle. So that's where the protons are because it's positive. And he noticed that there's a much lighter and negatively charged section of the atom on the outside where the rings are. So he theorized that those were the electrons. And then so he developed this idea of how atoms are arranged with their protons, neutrons, and electrons. So this is an example. If we ever ask you to draw a Bohr model, we're just asking you to draw a picture of an atom. So like here's an example for sodium. Here's an example for boron here at the bottom. Okay. And I believe that is the last slide for your notes. I do want you to go in and do your Nearpod assignment for this, because in the Nearpod, you'll have a fill in the blanks part. You'll have a picture of your periodic table square, and we'll figure out how to find the PNE for that. And then there's a little mini quiz at the end. It's not for a grade, it's just for you to check. But this is how we're taking your attendance. If you did not show up to the Zoom today or you were unable to make it, we'll take your attendance based on if you completed this Nearpod. So please go back in. Everybody who was in class today took the Nearpod while we did it, and they were able to answer all this stuff as we went along. But since you weren't there, or if you're watching this for the first time and you haven't done the Nearpod yet, please go do the Nearpod so we can count you as present for today. All right. If you guys have any questions, feel free to email us. We'd be happy to meet with you in advisory time, or we can answer your questions on email through Canvas or through your home access center. All right, guys, have a great day.